For the first example problem of the absolute dependent motion analysis of two particles, we have here determine the speed of block A shown in the figure if block B has an upward speed of 6 feet per second. So um, we have a given pulley system here, and the answer of the velocity of block A must be equal to 18 feet per second downward. So let us solve this first problem. So the first thing for you to solve this problem is to establish the position coordinate equation. So the position coordinate equation represents the total chord length in your pulley system. And for the position coordinate equation, it will be represented with the variable L, which represents the total chord length excluding the other chord length where its length will not change. So kaning mga chord length na dili mag-change ang iyang length is kaning naka-color red. So this one and kaning tolo that is um, wrapping around the pulley or within the arc nato. And also in the position coordinate equation, we need to identify our datum or what we call the fixed point. So that is actually the origin, which dire ang atong basis for the position sa atong mga points or the blocks. So dire ang basis sa to ang SB, which is this one, and also ato ang SA. So for the position coordinate equation, since isa naman siya ka chord length, so for this pulley system, it represent with one chord length. So ang makam up lang nato na position coordinate equation is only one equation. So let us um, establish the position coordinate equation. So that is represented with L, which is the total chord length, excluding the um, red colored lines and or the red colored chord length shown in the figure, which is equal to this 3. So this 3 is represented with SB. So that is 3SB plus the other chord length, which is the longer chord length, is represented with SA. Once we establish the position coordinate equation, we apply time derivatives. So for the time derivatives, we differentiate the equation with respect to time. So from the position, it will become velocity. And for this equation, L will become 0 since it is constant. So that will become 0 and equal to 3 VB. So SB is the derivative of SB with respect to time will become VB or the velocity of block B plus VA, which the derivative of your position for block A is the derivative of your position for block A with respect to time is equal to VA. So for this one, since we base on our data which is shown above, we identify also the positive sense. So we consider downward as a positive sense. So when we substitute a value in this equation, we base on the positive sense on our pulley system, since ang given man na velocity is VB, which is 6 feet per second upward, so itong VB is equal to negative 6 feet per second. So we substitute here in our equation, that is 3 negative 6 plus VA, and VA, or the velocity of block A, is equal to positive 18 feet per second. So the meaning of positive 18 is downward. So your final answer will be 18 feet per second downward, which is the velocity of your block A. So that is how you identify the velocity of block A. Um, Especially you start with the position coordinate equation, establishing the position coordinate equation, and applying the time derivatives. For the second example, the difference on the first example is that we have actually two chord lengths. So we have the first chord length, which is this one, and the second chord length. Since we have two chord length, we will establish two position coordinate equations. So in this second example, what we need to determine is the speed of block A that is shown in the figure if B has an upward speed of 6 feet per second. So the velocity of A is 24 feet per second downward. So just a solution for this one. So for the position coordinate equation, since it has two chord length, we will have two position coordinate equations. So the first equation is represented by this chord length. So we will represent that with L1, and that is the L1 is the total chord length excluding the uh, red colored chord length as shown in the figure. So that is this one, SA, plus this two, which is equal to SC. So that would be plus 2SC. For the second chord length, which is represented by this chord length, we will represent that with L2, and that is the total chord length excluding the chord length or the red colored chord length. So that would be this length, which is equal to SB minus SC, plus the other chord length, the longer chord length, which is represented with SB. Once we establish the position coordinate equation, we apply time derivatives. So it is the same of what we did from the first equation, first example rather. So for the first equation, that is 0 is equal to VA plus 2VC. Then for the second one is 0 is equal to VB minus VC plus VB. So we have two equations. since atong gipangita man diri is ang velocity sa block A, so from equation 2, we need to determine the equivalent of VC para i-substitute nato na siya sa equation number 1. So from equation 2, that is 0 is equal to VB minus VC plus VB. So that is 0 is equal to 2VB minus VC. So therefore, VC is equal to 2VB. So kaning equation na to, mao na to i-substitute sa equation 1. So from equation 1, that is 0 is equal to VA plus VC. So that would be 0 is equal to VA plus 2VB. And like what I've said, um, since we have datum here, um, we established already the datum or the fixed point here in the pulley system. So this is the origin. So going downward, we will consider that as a positive sense. So downward would be positive. And the given velocity is the velocity of block B, which is equal to 6 feet per second upward. So that would be equal to negative 6 feet per second. So when we substitute here, that will be VA plus 2 times negative 6, or VA is equal to negative 18 feet per second. Not 18, it is positive because you transpose that to the other side. So that is positive 18 feet per second. And since it is positive, our VA, the final answer of the velocity for block A, is equal to 18 feet per second downward. So that is the velocity of block A, which is 18 feet per second downward. For the last example, or the third example for this topic, it is actually the same with the second example kanina. So what we need is to determine the speed of block B shown in the figure if the end of the cord at A is pulled down with a speed of 2 meters per second. So the velocity of block B is equal to 0.5 meters per second upward. So just a solution for this one, since it has uh, two chords, two chord length, we have um, this one as the first one, and the second is from A until here. That is the second chord length. So we will have two position coordinate equations. So we need to establish the position coordinate equation. And naman tayo datum din sa to ang problem, which is shown here above. So going downward is the distance of our points or the blocks. So that are these are the SB, SC, and SA. So for the second chord length, first chord length rather. So for the first chord length, we will represent that with L1, which is the total chord length minus the red colored chord length. So kumuha na tong L1, di na to apilon ni the part, but only this portion and this other side, which is equal to SC and SB. So our L1 is equal to SC plus SB. For the second chord length, which is this portion, we will represent that with L2. And for the second chord length, if I will draw that, it will draw the chord length. We will include the total chord length minus the total length minus the um, red colored chord length na to. Really, they include din nila sa taas and also here and also of the datum, which is this one. So this length is equal to SB. This portion is equal to, if I will extend that, that is equal to SB minus SC. And this other portion that is equal to SA minus SC. So the L2 nato would be equal to SA minus SC plus SB minus SC plus SB. After we establish the equations, we apply time derivatives. So the first equation, that is 0 is equal to BC plus VB. So that is the derivative position with respect to time. And second is VA minus VC plus VB minus VC plus VB. So we have two equations. So what we need is we determine the velocity of block B. So for us to solve the velocity of block B, what we need is we determine the equivalent of VC, which we will get it from equation 1. Then we will substitute it to equation 2. So from equation 1, just a continuation, that is 0 VC plus VB. So our VC is equal to negative VB. So muna itong i-substitute sa equation 2. So from equation 2, that is 0 is equal to VA minus VC plus VB minus VC plus VB. So our VC is negative VB, so that is VA minus times the negative VB, so that would be positive VB plus VB plus VB plus VB. So we combine the like terms or the same variables, which we have 4 VBs, so that would be VA plus 4 VB. And for us to determine the velocity of block B, that would be negative VA over 4. And this lang to gibuhat sa first two equations, first two examples rather. Sa first two examples, since we have that term here above, going downward, we consider downward as a positive. So for VA, that is 2 meters per second downward, pag i-substitute nato sa equation, that is a positive 2 meters per second. So what happens here, this will be negative 2 over 4. So your VB is equal to negative 0.5 meters per second. And since it is negative, ang atong VB or the velocity of block B is 0.5 meters per second upward. So that is the answer of your velocity for block B. And again, when you solve for the absolute dependent motion analysis of two particles, it's very important that you establish first the positional coordinate equation, then afterwards you apply the time derivatives. So that will be all for the examples for the for this topic.